Pre-Algebra lesson 5.1. Comparing and ordering fractions. Okay, first thing first. Let's talk about least common multiple. Okay, to find the LCM. To find the least common multiple. The old way of doing this, so you're paying attention here, right? The old way of finding the least common multiple is just do what? List the multiples. So if I said the least common multiple of the numbers 4 and 6. Okay, what you would do is you'd list the multiples of 4 and list the multiples of 6 and find the least common multiple. In other words, the smallest same multiple. What are the multiples of 4? 4, 8, 12, 16, 20. The multiples of 6, 12. There we can stop right there, right? Because that's the smallest multiple. Do you remember what I'm talking about here? You've done this before. Least common multiple is the smallest same multiple. So list the multiples, you can find it. Now, the issue is that sometimes things get a little bit, well, I'm going to show you how to find the least common multiple of bigger numbers, okay? I mean big numbers like 12 and 40. Here's the deal. These are not too big, but how many of you would like to list the multiples of 12 and list the multiples of 40 and find out where those things land? I mean, like multiples of 12, oh boy, okay. 12, 24, 36, 48, 60, okay, and then the multiples of 40 are 40, 80, 120. Are we there yet? No, we're not there yet. Do we have a common multiple yet? Do we have a common multiple yet? Okay, then we got to keep going. 72. Oh man, do you see how this would get ugly and big? So then, to find the least common multiple of 12 and 40, here's what we're going to do. We're going to do prime factorization again. What's the prime factorization of 12? 2 and 6, which is 3 and 2. Okay, the prime factorization of 12 is 2 times 2 times 3. Yes? Okay. The prime factorization of 40 is 2 and 20. 2 and 10. 2 and 5. Prime factorization of 40 is 2 times 2 times 2 times 5. Here's how you use prime factorization to find the least common multiple. Okay, are you paying attention? What numbers are there in this? What different numbers are there? I have 2s, I have 3s, and I have 5s. Do you see what I'm talking about? 2s, 3s, and 5s. Which one of these has the most 2s in it? 40. So you're going to circle all 3 of those. Okay, does that make sense? You're going to circle all 3. Which one has the most 3s?
12.
Which one has the most 5s?
40.
What is 2 times 2 times 2? 8. 8 times 5? 40. 40 times 3? 120. 120 is the least common multiple of 12 and 40. Does that make sense? You understand what multiples are, Brad? So 120 is the least common multiple. Try it. Let's see if you guys can try one. Find me the least common multiple of 18 and 30. Find me the least common multiple of 18 and 30. Okay, so to find the least common multiple using prime factorization is you do prime factorization. 18 would be 3 and 6, which is 2 and 3. Agreed? So 18 is 2 times 3 times 3. 30 would be 3 times 10, which is 2 times 5. 30, 2 times 3 times 5. Here's the deal. This is how you do it. You look down here and go, okay, what numbers do I have? 2s, 3s, and 5s. Does that make sense? The prime factors are 2s, 3s, and 5s. Which one has the most 2s? They're tied. So you just choose one. Okay, you just choose one. Does that make sense? Just choose one of them. Which one has the most 3s?
18.
The top does. Which one has the most 5s? Right here. What is 2 times 5?
10.
10. 10 times 3 is 30. 30 times 3 is 90. The least common multiple of 18 and 30 is 90. Does that make sense? Okay. I'm going to give you guys one more to try using that. Just one. Let me see. I'll give you a good one. 42 and 210, a big one. Least common multiple of 42 and 210. Prime factorization of 42, what could I put? 6 and 7, that's prime. 2 and 3, all prime. Prime factors of 42 are 2 times 3 times 7. Prime factors of 210 is 21 and 10. Anytime there's a 0 at the end, that's an easy one. 21 and 10, which is 7 and 3, and 2 and 5. So 210 is 2 times 3 times 5 times 7. Which one has the most 2's? So which one do I choose? It doesn't matter. Which one has the most 3's? Which one has the most 5's? Which one has the most 7's? 2 times 3 times 5 times 7 is 210. So the least common multiple is, what is 41? What is 42 times 5?
210.
Does that make sense? Anyway, let me show you then how to do this using variables. Understand this. The whole point of this is that you follow the same pattern. Nothing changes. Just because all of a sudden we put variables in there, the pattern doesn't change. 12x squared y, and the least common multiple of 12x squared y, and 20x y z. Okay? Makes sense?
Yep.
Prime factorization of 12, 2 and 6. Oops, that 6 shouldn't be circled. And then 2 and 3. Okay, prime factorization of 20 is 2 and 10, 2 and 5. Okay, well, let's look then. So the prime factor of 12x squared y is what? 2 times 2. I'm going to use a dot. 2 times 2 times 3 times x times y, right?
Yeah.
We've done this. Prime factorization of 20xyz is 2 times 2 times 5 times x times y times z. So what do we see here? What are we looking at? What are the prime factors? We have 2's, 3's, x's, y's, and 5's, right? Right? Which one has the most 2's? Which one has the most 3's? Which one has the most 5's? Which one has the most x's? Which one has the most y's? Which one has the most z's? Now you just multiply everything you've circled. What is 2 times 2? 4 times 5? 20. 20 times 3? 60. So we know it's 60. And then x times x is x squared y z. Does that make sense? Follow the same pattern. Nothing changes just because there's variables. You have to memorize the pattern. That's all there is to it. You guys try one. Try 25y squared and 15xy. Find me the least common multiple of those two. Okay, so prime factorization of 25 is
5 and 5.
5 and 5. Thank you. Prime factorization of 15 is 3 and 5. Okay, so the prime factorization of 25y squared is 5 times 5 times y, right? Okay, prime factorization of 15xy is 3 times 5 times x times y. What do we have down here, guys? 3's, 5's, x's, and y's. Which one has the most 3's? Which one has the most 5's? Which one has the most x's? Which one has the most y's? What is 5 times 5? 25 times 3? Xy squared. See it? You'll see it. Difficult? No. Now, the other thing you have to do is this. Comparing and ordering fractions. I'll tell you this. One thing you need to be able to do is estimate all the time. I'm surprised they don't have us estimating fractions first, but I'll tell you that most of the time, whenever they say to compare and order fractions, let's go 1/5, 2/3, 12, 12 20ths, and 8 15ths. And if I was going to ask you to just look at it up here, you're looking up here. If I was to ask you to compare these and order these, here's what you do. You should be able to tell when something is close to 0, when something is close to a whole number, and when something is close to half. Does that make sense? You should be able to do that. 1/5, what's that pretty close to? If you took a number line and went from 0 to 1, where would 1/5 land? Is it close to 0? Close to 1? Is it close to the middle? Where would 1/5 land? It's pretty close to 0, right? I mean, it's going to be over here somewhere, right? So he's far left. But okay, we're going to put 1/5 down here just so we can kind of see. Okay, 2/3, where does that land? We already know that lands on the other side of half, right? I mean, here's a half. We know that this is 1/2 here, right? And so 2/3 is bigger than a half. Do you agree? I mean, you all have that in your head? That means it's going to be over here somewhere. And then 12 20ths, is that bigger or less than a half?
Bigger.
It's bigger than a half, right? And so you go, okay, that one and 2/3 is going to be pretty close to each other. We might have to do something about that. But it's going to be a little over here, right? It's going to be in that region. 8 15ths, also just barely over half. Does that make sense? We also know it's going to be over here. Just being able to, in your head, look and go, this one's less than a half, and these other three are all a little bit bigger than a 1/2, will let you know that, what's the smallest one? 1/5. You just know that. Does that make sense? I mean, you can do a lot of this stuff in your head. Now, they're asking us to do things like using the least common multiple to find the differences between, 12 20ths, which reduces to 12 20ths reduces to 3/5, right? 3/5. And the other one was 8 15ths, which doesn't reduce, right? But let's just compare these two. How would we compare those two? 3/5 and 8 15ths. What do you do to compare them? 3/5 and 8 15ths. Do you remember what to do? Got to get the same denominator. The way to do that is to multiply, cross multiply here. What's 5 times 8? 40. What is 3 times 15? Which one's bigger? The 45 is bigger. Therefore, that one is bigger than this one. Does that make sense? It's that simple. Another way of doing this, and if you had a calculator, if I allowed you to use a calculator, all you need to do is this. If I have 3/5 and 8 15ths, is type it in. This is a division problem. What is 3/5? When you type in 3 divided by 5, does anybody know what it comes out to? Without using a calculator, you should. 3/5. What is that? When you type in 3 divided by 5, 0.6. 8 15ths comes out to like 0.55 or something like that. Which one's bigger? 0.6. Right. This is bigger. Therefore, 3/5 is bigger. Does that make sense? A lot of them, though, you're going to be able to do this right here. They'll have 2/7, 8/9, and then they'll have 3. No, they'll do a big one, 31/60. And you go, okay, can you order these for me without doing any math? Can you look at those and put those in order for me without doing any math at all? I can.
Yeah.
Which one's the smallest? How do you know?
Because it's less than half.
It's less than a half. It's way less than half. 8/9 is almost a whole one, right? And 31/60 is right near half, right next to half. So you can just by looking at these and understanding the concept of fractions, you can do most of this. I mean, in almost all of the questions here, when they have you compare four, two of them are going to be obvious. There's obviously going to be the smallest one, and then there's going to be the biggest one, and you might have to deal with the middle ones or, you know, something. But most of them you're going to be able to do in your head for real, for real. When you start dealing with negatives, which one here is bigger? Negative 4/9 or negative 2/9? Which one is bigger? Negative 2/9 is bigger, right? This one is a bigger. This one's a bigger negative, right? Which means it's further to the left. Make sense? Okay. Yeah, I think that's. What if I was? Let's give you one of these. We're going to give you one that's way harder than normal. Let's go. I want the least common multiple of this. We're going to go 12x squared y and 20y z and 30x y squared z. I want the least common multiple of those three. Nothing changes just because it's bigger or uglier. Follow the rules. You can do it. Least common multiple of 12x squared y, 20yz, and 30xy squared z. Find the least common multiple by using prime factorization. Prime factorization of 12, again, is 2 and 6, 2 and 3. Okay, so we're going to come down here. 12x squared y is what? Tell me again exactly. 2 times 2 times 3 times x times y, right? Prime factorization of 20 is 5 and 4, 2 and 2. Okay, so 20yz is 2 times 3, not 2, 2 times 2 times 5 times y times z. Prime factorization of 30 is 3 and 10, which is 2 and 5. So then we have the prime factorization of 30x y squared z is 2 times 3 times 5 times x times y times z. What do we see down here? What do we have down here, girls? 2's, 3's, 5's, x's, y's, and z's, right? Which one has the most 2's? Either one, right? One of those, okay? Which one has the most 3's? Either one. Okay, we'll go down here. Which one has the most 5's? Either one. Which one has the most x's?
12.
Which one has the most y's? Which one has the most z's? It doesn't matter. Now you just multiply what you've circled. 2 times 2 is? 4 times 3? 12. 12 times 5? 60. X squared y squared z. Make sense? You guys can do everything now. For sure. Your homework. Okay. Page 235 to 236. 31 through 56 even.